Hi there, my name is Danny Tamburino, co-founder of Optimum Accessory Dwelling Units. It's great to be here with you today, and thanks for joining us. Today, we will once again be continuing our series on the secondary suite design guide for the City of Edmonton, and we will be zeroing in on the section titled Structural and Building Changes. But before we get into it in detail, I would like to once again take a quick review. As previously mentioned, this series is all about secondary suites, and we are taking our viewers step by step through the City of Edmonton's design guide for the development of these suites. A secondary suite is simply a separate dwelling located inside a single detached house, semi-detached house, duplex house, or even a row house, with its own cooking, sleeping, and bathroom facilities. These suites are typically basement suites, but they can also be garden suites or garages with suites above, also known as accessory dwelling units. Secondary suites must have a separate entrance from the rest of the home and can be created through the conversion or development of a basement or other interior space. In some instances, when we as qualified contractors are asked to convert or develop a basement or other interior space into an accessory dwelling unit, the changes requested may require either structural or building changes, and oftentimes both. For someone who is not familiar with the residential home construction process, or for someone who has no previous knowledge of construction at all, it can be very difficult to understand what this section is all about. Throughout our discussion today, we will give you an overview of what the new home construction process looks like, and we will be doing this by referencing materials from the Canadian Home Builders Association website. We will be talking about such things as pre-construction, foundation, framing, and interior and exterior work. Because the most typical secondary suites are basement suites, I believe that it is important to have a general understanding of new home construction before we can begin to talk about things like structural and building changes and terms like beams, columns, bearing walls, and floor frames. We here at Optimum Accessory Dwelling Units are all about helping people create positive cash flow through secondary suite development. We not only specialize in building accessory dwelling units, we have developed a proven system on how to properly design, build, and budget ADUs for optimum investment potential, and we typically start with an existing home. So let's get right into it. The construction process. Phase 1, pre-construction. Before any construction begins, plans for your home are developed, finalized, and submitted to the Municipal Building Permit Office for review. Permits may be required for all or some of the following work: building, electrical, plumbing, septic system, and sewer connection. Prior to this, a number of site tests may be conducted to examine the water table, the soil, and the bearing capacity of the ground, and to conduct environmental tests. With this information, final engineering adjustments can be made to the plans. Phase 2, foundation. Your house is staked out and the land is prepared. Often, the topsoil is removed and piled elsewhere for later use. Excavation is done and the footings are formed and poured. Water, electricity, telephone, and cable services may be brought in at this time. The foundation walls are erected and then may be insulated and damp-proofed. Drainage is installed to keep ground moisture away from the house. A municipal inspection of the foundation may be conducted before the outside perimeter is backfilled. At this time, the builder may ask you to begin making your selections, deciding on flooring, tiles, cabinets, and so on. While it will be weeks before these items are installed, they must be ordered early to prevent delays later. Phase 3, framing. Exterior walls, interior partitions, and the roof are assembled. This usually means erecting a framing skeleton and applying an exterior sheeting. Once the house is fully framed, windows and doors are installed. The builder's aim is to get the house to lock up, where it is closed as quickly as possible to protect the structure from the elements. The basement floor is then installed, electrical and plumbing services are roughed in, and ducting for heating, cooling, and ventilation is put in place. At this time, your municipality will probably require a structural inspection. Electrical and plumbing inspections will likely be conducted as well. So let's pause the construction process for a minute and talk about structure. What makes up the main structure of a house? The basic components of a building structure are the foundation, floors, walls, beams, columns, roof, and stairs. These elements serve the purpose of supporting or enclosing and protecting the building structure. So when we look at page 9 of the Secondary Suite Design Guide for the City of Edmonton, under the heading Structural and Building Changes, it states that to accommodate suite construction, structural changes may be made as part of the suite project with good information provided. So we, as qualified contractors, are able to make structural changes, provided we follow all of the guidelines set out by the City of Edmonton and also provide engineer stamp designs for many instances, which we will talk about in a few minutes. Back to understanding structure. Structure begins with footing and foundation. Footings are concrete slabs that support the foundation walls, and both are made of formed and poured concrete, reinforced with steel rebar. Beams and columns are two important types of structural elements that play a key role in creating a safe load path to transfer the weight and forces on a structure to the foundation and into the ground. Beams are usually horizontal structural elements that carry loads perpendicular to their longitudinal direction. Think of a balancing beam in gymnastics. It's a rectangular object 15 feet long and supported at both ends. When a person is walking on the beam near the middle of the span, then weight is a vertical downward force acting perpendicular to the longitudinal direction of the beam. Beams are used to support the weight of floors, ceilings, and roofs of a building, and to transfer the load to a vertical load-bearing element of the structure. Columns are vertical structural elements where the load is transferred parallel to the longitudinal axis as compression and sometimes as tension. For example, think of a rectangular table with 4 legs at the corners. The weight of the table and all the objects on the table is transferred to the floor through the legs acting in compression. In this case, the legs can be considered as columns. Columns are used to support floor or roof beams and the columns of the floor above. The columns at the bottom floor of a tall building must carry the accumulative weight of all the floors above. This is why the location of columns ideally should be consistent throughout all floors. A bearing wall, also called a load-bearing wall or structural wall, bears the weight of the house from top to bottom. This wall helps disperse the building's weight from the roof down to the foundation, and its removal could cause the structure to collapse. This is the wall structure that most people doing interior renovations or suite development are most concerned with for obvious reasons. Removing walls to open up interior spaces is very popular, but if done without knowledge and care, can be very dangerous to the integrity of the existing structure. As an aside, there are ways to determine if a wall is load-bearing. Generally, when the wall in question runs parallel to the floor joists above, it is not a load-bearing wall. But if the wall runs perpendicular or at a 90-degree angle to the joists, there is a good chance that it is load-bearing. However, there are cases where a bearing wall is parallel to the joists, and that is why it is best to always consult a professional. Don't try to skip ahead, consult a professional. Floor framing includes all structural components and fasteners used to construct floors in a house or commercial building. This term is typically used to describe floors made from wood or I-joists as opposed to those constructed using concrete slabs. All of these terms are used in describing the most common framing technique in modern residential construction called platform framing, in which each story is framed on top of the previous one. So now that we have a greater understanding about structure, we can get back to the construction process and phase 4, interior and exterior work. For the next several weeks after framing, a great deal of work will happen inside and out, much of it at the same time. The exterior walls in the roof are insulated and a vapor barrier is applied. Another municipal inspection may take place to ensure this work has been done properly before the drywall is installed. Heating and cooling systems are installed, including fireplaces. Walls and ceilings are painted, flooring is laid, and kitchen and bathroom cabinets are installed. Plumbing and electrical fixtures are put in and trim is applied, and interior doors are hung. Siding or other exterior finishes are applied on the outside, along with eavesdropping, and porches and decks are installed. Final lot grading is done, and the driveway and walkways are put in. Several additional municipal inspections may occur. For instance, after completion of the interior to check stairs, handrails, and other health and safety related items, and or after final grading outside. Plumbing and electrical work will require final inspection. So when we are talking about structural changes in regards to secondary suite development, what exactly is considered in structural change? A structural change refers to any modification that involves fixing, changing, removing, or adding any load-bearing elements. A load could either refer to weight or pressure. These elements could include posts, beams, columns, and of course, the home's walls and foundation. According to the Secondary Suite Design Guide for the City of Edmonton, engineer stamp drawings is required, or engineered stamp design is required for changes to a foundation wall where any of the following conditions is present. The existing typical cast concrete foundation wall is degraded due to poor original quality or placement, age, soil conditions, adjacent driveway stresses, or poorly drained soils subject to freeze-thaw cycling, and so on. This is basically wear and tear by the elements on an existing older home due to the harsh temperatures we endure in the winter months. Engineer stamp design is also required for enlarging an existing opening or making a new opening in a typical cast concrete foundation wall where the result is in a window opening more than 1.2 meters wide. This situation occurs when wanting to enlarge window sizes to meet current building code for egress or for allowing more light to enter the dwelling. Engineer stamp design is required for enlarging an existing opening or making a new opening in a typical cast concrete foundation wall where a point load from any beam or wall opening exceeding 3 meters in length is above or within 12 inches of the proposed opening. This one is dealing with structural point loads and the potential compromise of the integrity of the building structure itself. Engineer stamp design is once again required when the length of foundation wall remaining between any two window openings is less than the average of the width of the two window openings. This one is dealing with the integrity of the foundation and once again, part of the overall structure of the home. Engineer stamp design is also required when the sum of the widths of all opening on one foundation wall face after alteration will exceed 25% of that wall length measured from the interior side. This is self-explanatory in that the openings on one foundation wall cannot exceed 25% of the entire length of the wall. Engineer stamp design is also required when a window opening is to be cut or enlarged in any PWF or permanent wood foundation wall, ICF or insulated concrete foundation wall, precast, block, or brick wall, or a new basement level entrance is proposed. Engineered design is also required for the retaining wall and new and existing footing frost protection. This brings us to the conclusion of the section titled Structural and Building Changes from the Secondary Suite Design Guide for the City of Edmonton. Remember, structural changes are allowed to be made, but only with good information provided. We at Optimum ADU hope that this informational video has helped you in understanding the requirements on structural and building changes for secondary suites in Edmonton. Whenever you are planning on making any structural changes to your existing home, it is highly recommended that you consult a professional contractor who works closely with a structural engineer to guide you through your secondary suite development. Building and building processes are serious business and require a lot of attention to detail as well as significant knowledge of construction. At Optimum ADU, this is our specialty, and we would love to be your optimum choice on your next accessory dwelling unit project. My name is Danny Tamburino. Thank you for watching and see you next time.